Okay, 8.4 proportionality theorems. Theorem 8.6 and 8.7 are converses. 8.6 is the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. What that's talking about is this side here, TU, it is parallel to QS. So it's telling us that it divides the other two sides, the two sides that are not highlighted, proportionally. What that could mean is that we could say, well, TR over QT is equal to UR over SU. Right? We took the big piece over the little piece, and then in the other one we took the big piece over the little piece. Okay? Now you can flip these, you can put the little pieces on top, but you have to put both little pieces on top. And I don't think I read it, but 8.7 is the converse. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So that would be saying something like, if you were given this, then you could draw this picture. Number 1, find YZ. So I've already drawn in an X there because I don't really want to have to use two variables, the Y and the Z together. So we're going to kind of plug into this proportion over here. We're going to put the long side on top. That way we can put X on top. X over 5 equals the long part 10 over 4. Whenever I multiply by 5, I get X equals 50 over 4, which is 25 over 2. There we are. If we wanted to write it back in terms of the problem, we could say YZ equals 25 halves. Eight 8.8, three parallel lines theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. And this is kind of an extension of the triangle proportionality theorem. So we have lines L and M are the transversals. R, S, and T are all parallel. So here we have UW is this, WY is this here, and then VX is here, and XZ is there. Okay, so they took from the same transversal the first piece and then the second piece. Then they go to the other one, and they go back to the first and the second. So part 2, find DF. So DF is this whole thing here. What I'm going to do is I'm just going to find X first, and then I will add X and 35 together. So our three parallel lines, they're kind of slanted to the right, right? So I'll take the left piece first. Well, actually, I'll take my X first. X is the right piece over 35. And then I'm going to go to the other transversal, and the right piece is 12 over 30. Multiplying by 35, I get X equals 12 times 35 over 30. And I'm just going to type that in the calculator. 12 times 35 divided by 30. That gave me 14. So X equals 14. So DF is going to be 35 plus 14, which is what? 49. There we are. Theorem 8.9, the triangle angle bisector theorem. If a ray bisects, cuts in half, an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other sides. So let's look at this picture here and see what that means. Angle C here is bisected, right? We see the little swoops right there. And it tells us that the opposite side, AB, is cut, not necessarily in half, but it's cut. And AD, which is the first piece, is proportional to, over DB is equal to CA over CB. Right? So they took the left cut over the right cut equals the left side over the right side, right? If you're looking at the perspective of C. Let's look at number 3. So I want to find Y. I want to be able to put Y on top. Y is the right cut, so I'm going to put it over the right side, 63. Then I'm going to go to the left cut, 18, over the left side, 42. I multiply both sides by 63 to get Y equals 63 times 18 over 42. And I'm going to type that in, 63 times 18 divided by 42, and I got 27. That's supposed to be a multiplication sign. 27. So Y equals 27. All right, there we are. Now, whenever you go and do your homework, make sure that you have these pictures drawn. I think those pictures are very useful. And a lot of the homework is just going to be difficult to set it up, right? Once this is drawn, or once you've got this set up, I think that's pretty easy to solve. I think most people in this class will think that's pretty easy to solve. But getting that written will be the issue. That'll be difficult. So make sure that you have all of these theorems written down, right? How many are there? There's 4 total, but really there's only 3 because 2 of them are converses. All right, so good luck on your homework, and let me know if you need any help.